It's time to finish up with our study in geometry, which is a study of how we do math with different shapes. Now, not that we will not be reviewing geometry as we get closer to the end of the year, because we will be reviewing all the different subjects that we have gone through once we get through Unit 10, which is dealing with statistical math. So when I start looking at Lesson 9.6, then just a quick review what we did. We went through lessons 9.2 through 9.4, which was the surface area of nets or three-dimensional shapes. And then we went back to lesson 9.1, which introduced us once again to our fifth grade standard of volume. And we started with just looking at the idea of rectangular prisms. And one of the things that I pointed out was the idea on a rectangular prism, if I get the measurement of the area of the base, which would be base times height or length times width, when it comes to your three-dimensional shape, that would either be a square or a rectangle, then I simply multiply by the height. So that's why we have length times width times height for a rectangular prism. Then we added another lesson. We added a 9.5, which was not in the book. We looked at the volume of triangular prisms. Once again, starting with the idea that if I find the area of the base, and the base in a triangular prism, as the book says, is always the triangle itself. So we did base times height divided by 2, found the area of the triangular base, and then we multiplied it by the height. And now we're going to go a step further. So as we come to our last lesson in geometry then, other than our review that we'll do throughout the remainder of the year, then we're looking at lesson 9.6, and we're looking at volume of cylinders. And once again, cylinder is a three-dimensional shape. When we look at the formula for the volume of a cylinder, then we can see that it is pi r squared. Notice that floating dot in the middle, once again means to multiply, and then I would multiply it by height. Well, why must I go back to using pi? Well, as we can see, when it comes to a cylinder on things such as pop cans or cans of soup, that the top and the bottom are indeed circles, and therefore I must find the area of a circle first and then multiply it by the height. If I look at my net document, then I can see that what makes up a cylinder is a rectangle. That's the height of the shape, and I would be able to lay it flat with a circle on top and a circle on bottom. Therefore, as we're looking at it, sometimes we have to realize that we're not going to be given r, and if I'm just given the diameter, then I have to do a quick math problem of taking the diameter and dividing it by 2. It's easy enough to find the radius, but make sure you're using the radius as you go through these math problems. And then to try to make it a little bit easier for you, we're going to use 3.142 on our first assignment here for the pi that we need to plug into our math formula. We'll get into that as we work through these problems. So as I'm looking at the volume of this cylinder, then I have to find some important information. Am I given my radius? I am, so I don't have to worry about dividing it, right? So I want to find, once again, my first step, the area of my circle. My area of my circle, once again, is pi r squared. And pi r squared, we put that floating dot in the middle to show multiplication. I personally don't like to put an x when I'm showing pi r squared because some people just think that's an x and therefore it's a third variable in a math problem when it actually would just be meaning multiplication. I also like to put it around parentheses. You won't always see it around parentheses, and quite often you probably won't in other books. But I like to set it off by parentheses so that I know that I'm going to find the area of my circle first, area of my base, and then I multiply by my height, and that's how I'm going to find volume. So that's why this formula is what it is, and I would strongly advise that you write it down so that you can make sure that you use it each and every time. When I'm given a formula, then I plug in the information that I know. Once again, on our next lesson, you're going to see where I'm given the volume and then I'm missing one of my measurements. So I therefore have to be able to plug in the information of what I know. Once again, pi is normally in sixth grade 3.14159. Now, what that means is, once again, pi goes on forever. That's what that dot, dot, dot means, that you can start it and then you're in your last breath still be dividing and coming up with remainders, but you'll see that there's never been a repeating pattern that's ever been found when dividing pi. But once again, what does that mean? So when we look at measurements of circles, right, we have a diameter, the distance going across from side to side, passing through the center. And we have a circumference, which is the measurement of the circle all the way around. In a straight-sided shape, that would be known as perimeter. In a circle, since it's all rounded, it is known as circumference. And what we find is that if I take 3.14 diameters, then I end up with a circumference. Or what we find is if I take my total circumference, if I take a string and wrap it around that circle, and then I divide it into all the diameters, that I get 3 with a little left. So you'll notice that those pink sections going around that are dotted, they're indicating how many diameters there are, with that little bit of section in the black indicating that there's 0.141592635897993, so on and so forth, forever and ever and ever. So once again, what we're talking about is if I take my circumference of my circle, I divide it by the diameter, the distance from side to side going through the center. That's what pi is equal to. No matter how big, no matter how small the circle is, it always ends up as 3.14159, so on and so forth. So as we're doing these, though, instead of using 3.14159 and making you do the math with 5 decimal positions, we're going to round it to 3.142. So if I look at that third decimal position known as the thousandths place, and I see that it's a 1, my indicator would be the 5 to the right, and that tells me to round up to the next number. So that's why we're going to use 3.142 when we do this first assignment. Now I'm going to plug in the information that I know. I have my radius that's given, so I know that I have r is equal to 6. But it's squared, and once again, that's not multiplying it by 2, that is multiplying 6 by 6. So when I plug that in into my equation, then I'm also going to look at the height, and that is 11. So now I plug everything in that I know. I know I'm using 3.142 for pi. I know that my radius is 6, so I'm multiplying that by r squared, which is 6 squared, and then I'm going to multiply it by my height. So I'm going to go through my order of operations. I can see that I have exponents and I have parentheses. Now, you'll see that we do have math problems occasionally where there's an exponent on the outside of parentheses, and that means you would have to do all the math inside the parentheses first, and then use that exponent. However, in this case, we have the exponent inside. So we're going to start on the inside of the parentheses, solving for the exponent. Then I go through with my order of operations, all my multiplication and division from left to right, and then my addition and subtraction from left to right. So we're going to start with 6 squared, which looks like, mathematically, once again, 6 times 6. The exponent tells me how many times to multiply the base by itself. So when the exponent is a 2, the base is a 6, I'm multiplying 6 by 6. Well, 6 times 6 is 36. And then I want to plug in all my other information. Once again, I'm rebuilding my math problem according to the formula that is given. Now I have to follow my order of operations and do my parentheses. So I'm going to take 3.142 times the 36, and I'm going to start with multiplying by 6. 6 times 2 is 12. Put down my 2, carry my addition of 1. 6 times 4 is 24, plus 1 is 25. Put down my 5, carry my addition of 2. 6 times 1 is 6, plus 2 is 8. And then 6 times 3 is 18. Once again, I have a second number. My second number always tells me to bring down 1 0. And then I can multiply by my second number. So now I go back to the 3 and I do 3 times 2, which is 6. And then 3 times 4, which is 12. I put down my 2, carry my addition of 1. 3 times 1 is 3 plus 1 is 4. And 3 times 3 is 9. I have them all lined up nice and neat. I know once I've multiplied and found their products, I'm going to add them together to find their sum or their total. So starting on the right-hand side, 2 and 0 is 2, 6 and 5 is 11, put down my 1, carry my addition of 1. 8 and 2 is 10 plus 1 is 11, put down my 1, carry my addition of 1. 8 and 1 is 9, plus 4 is 13, so I put down my 3, carry my addition of 1. And then 9 and 1 is 10 plus 1 is 11. Now, since I multiplied, I look and I remind myself, that I have decimal positions. So I count my decimal positions, and there are 3 of them. So I'm going to move my decimal point from right to left a total of 3 times. I put my decimal, and then that's the number that I'm going to use in my math problem. So in my math problem, I have 113.112, or 113 and 112 thousandths. That is the area of the circular base. Now I have to multiply it by the height. So we found area, and if I was showing my labels in my math formula, then I know area is always squared because we multiplied 2 things together. And when I'm multiplying by my 11, that's just a straight edge, so that's a straight measurement. Notice when I have feet with an exponent of 2 and feet that doesn't have an exponent, once again, that's an understood exponent of 1, then 2 plus 1 makes 3. And once again, we're finding volume, which is cubed. Let's go to the math. So I'm going to take my 113 and 112 thousandths and multiply by 11. Once again, I love multiplying by ones because it makes my life so much easier. When I multiply by 1, I'm going to write those numbers down in the correct order. But then I go to my second number and I have to bring down my 0 each and every time. Then I can multiply by 1 again and line them up, making sure that everything is in the correct order. Now that I have my 2 products, I'm going to add them together to find their sum or find their total. I'm going to go 2 and 0, which is 2, 1 and 2, which is 3, 1 and 1, which is 2, 3 and 1, which is 4, 3 and 1, which is 4 again, 1 and 1, which is 2, and then 1. How many decimal spaces did I have in my math problem? Well, I had 3 decimal spaces, so I'm going to move from right to left 2 times. So what I see is that I have 1,244.232. When I look at my answer then, I have to think, do I want to keep it that way? Well, in the directions on your notes and on your assignment, you're going to see that I'm going to ask you to round to the nearest hundredth. So when we think about hundreds, we have to think about our decimal positions. Once again, this is something that was taught several years ago for you. You need to work on learning your decimal positions. One of the ways that you can remember is for tenths. Once again, if I write 10 cents in dollar form, it's 0.10, and therefore that's the tenths position. If I'm doing hundredths, that's a penny, that'd be 0.01. That's 2 decimal positions. If you can just remember that it starts with tenths, then hundredths, then thousandths, 10 thousandths, 100 thousandths, then you'll remember the correct order. Just keep in mind there's no ones, ever. So if I'm rounding to my hundredths position, that is always the second decimal position. Well, in this case, that's a 3. Once again, my indicator is always, always, always to the right, so I circle it. And then that tells me, according to my rounding rules, that I'm either going to keep the 3 the same or I'm going to round up. Well, the 2, the indicator, tells me that I'm going to keep the 3 the same. Therefore, the 3 has to stay. And since the 3 stays and it's a decimal, everything behind it is simply going to drop off. So I end up with 1,244 and 23 hundredths. What about my label? Right? So once again, we're finding volume. And if you just commit to memory that volume is always going to be cubed, then your life is going to be a lot easier. However, if we go back once again, seeing that when I found the area of my base, I had a squared label, and then I multiplied it by the height, which is another label. So there were 3 groups of feet in that multiplication problem. But once again, the easiest way is just to remember that volume is always cubed. So the label for this one is going to be cubic feet. So the answer for question number 1, if you're following along, you have 1,244 and 23 hundredths cubic feet for the volume of the cylinder. All right, what about practice 2? All right, so going a little bit quicker through the next two. If I'm going too quick, then just pause the video and make sure you get your notes down. You can once again write down your notes and then go back and just listen as I'm going over it so you can understand and comprehend what's going on. All right, so on your second one then, we have this cylinder. We're going to use the same information. Once again, we're looking for our radius, for our base, and we're looking for our height of the shape. When I'm doing pi r squared, my radius, once again, from the center to the outside of the circle, in this case, it's showing me that it's 4. So I set up my original information. I have pi times 4 squared times the height. Well, the height in this case is 13. So I know I want to use pi as 3.142, and I have the 4 as my radius, so that's going to be 4 squared. Put those in parentheses so that I can find the area of my circle base first. Then I multiply by the height, and in this case, that is 13. All right, so I start with my order of operations. Once again, I have parentheses and exponents together. The exponent is inside the parentheses, so that's why I have to start with the exponent first. Then I can do my other multiplication and addition and subtraction if I have it. 4 times 4 is 16. Everything else comes down. So now I have the pi, the 3.142 times the 16, which is the r squared. I'm going to do that first because it's in my parentheses. So I go to the side and I write out 3.142 times 16, and I start multiplying by my 6. 6 times 2 is 12, put down my 2, carry my addition of 1. 6 times 4 is 24, plus 1 is 25, put down my 5, carry my addition of 2. 6 times 1 is 6, plus 2 is 8, and then 6 times 3 is 18. Once again, the second number tells me to bring down a 0. And once again, I'm multiplying by a 1. So all I have to do is copy down the 3142 in the correct order. Now I can add those together. Starting at the far right, I have 2 and nothing, so it's 2. 5 and 2 is 7. 8 and 4 is 12, so I put down my 2, carry my addition of 1. 8 and 1 and 1, that's 10, put down my 0, carry my addition of 1. And then 3, 1 and 1 is 5. Now I have the correct number. So now, once I have my answer, then I'm going to count my decimal spaces. Once again, in my math problem, I have 3, so I'm going to move my decimal point from right to left 3 times. So what we found is that the surface, or the area, excuse me, of the circle is 50.272, or 50 and 272 thousandths square inches. But I still have to multiply it by the height, which is 13 inches. So when I do that, I stack it 50.272 times 13 and multiply by my 3. 3 and 2 is 6. 3 and 7 is 21. Put down my 1, carry my addition of 2. 3 times 2 is 6 plus 2 is 8. 3 and 0 is 0. And 3 times 5 is 15. Once again, I have two double digits here, so I'm going to take my second number and it tells me to bring down a 0. And then if I'm multiplying by that 1, that's great because then I just have to put my numbers down in the correct order. Now I can add them and I get 6. 2 and 1 is 3. 8 and 7 is 15. Put down my 5, carry my addition of 1. And 2 plus 1 is 3. Then I have 5 and 6. How many decimal spaces did I have in my math problem? Once again, I had 3. So I'm going to end up, start out with, is 653 and 536 thousandths. But once again, we want to round to our nearest hundredth. So I underline my hundredths position. Once again, it's always the second decimal position to the going from left to right. And then I indicate, so I should circle my indicator, which is 6. Then I ask myself the questions. How do I round? Well, if it's 0 to 4, I'm going to stay the same. If it's 5 to 9, I'm going to round up. The 6 tells me I'm going to round up. So my 3 becomes a 4. Everything in front of it stays the same. Everything behind it, since it's a decimal, I simply get rid of it. So I end up with an answer of 653 and 54 hundredths. And what is my label? Well, it's volume, so it's going to be cubed inches. All right, so our last one, I set up a little different for you just to make sure that we're doing all the steps that we need to. So once again, I have a cylinder, but notice what I have. I don't have a radius, I have a diameter. And reminder that when I have a diameter, I have to divide it by 2 to find out what my radius is. So if I take 10 divided by 2, then I know my radius is 5. And now I can plug that 5 into my formula. So volume of a cylinder, its formula is pi r squared, all multiplied by height. I know that I have pi times 5 squared times the height. We're going to plug in what my height is. Well, that's 9, and I know that pi is 3.142 in this set of problems, so I plug in my extra information. In parentheses, I'm going to find the area of the circle, which is the base. So I'm going to take 3.142 times 5 squared, all then multiplied by the height of 9. So I'm going to do my 5 squared first, which looks like 5 times 5, which is 25. I bring everything else down. I focus once again on my parentheses now. I'm going to solve for the area of my circle. Multiplying by 5, 5 times 2 is 10, put down my 0, carry my addition of 1. 5 times 4 is 20 plus 1 is 21. Put down my 1, carry my addition of 2. 5 times 1 is 5 plus 2 is 7. And then 5 times 3 is 15. My second number tells me to bring down a 0, and then I multiply by my 2. And 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2. And then 2 times 3 is 6. Now I can just simply add those together, going from right to left. I have zeros. 4 and 1 is 5. 8 and 7 is 15. Carry my addition of 1. 5 and 1 is 6 plus 2 is 8. And then 6 and 1 is 7. How many decimal spaces are in my multiplication problem? Well, there are 3, so I'm going to move that decimal from right to left 3 times. Now, when I do my next step, I notice that I have a decimal ending with a 0. That just gives me an extra decimal position that I have to work with, so I'm just going to get rid of it. I don't like having to work with more decimal positions than I need to. So instead of having 78.550 multiplied by 9, I'm just going to make it 78.55 multiplied by 9. It won't change my answer because if I use the 0, then I have to move my decimal 3 times. Since I'm getting rid of it, I only have to move my decimal 2 times. Now I multiply by my 9. 9 times 5 is 45. Put down my 5, carry my addition of 4. 9 times 5 is 45 again, plus 4 is going to be 49. So put down my 9, carry my addition of 4. 9 times 8 is 72, plus 4 is 76. Put down my 6, carry my addition of 7. And 9 times 7 is 63. 63 plus 7 is 70. I have how many decimal spaces in my math problem? 2. So I'm going to move my decimal point from right to left 2 times. So I end up with 706.95 or 706 and 95 hundredths, and we want to round to our hundredths, so it's already there. So I simply have my answer of 706 and 95 hundredths, and then I remember that since I'm doing volume, my label is cubed. All right. So hopefully you find that this isn't too difficult of a lesson. Once again, I'd have that formula written down and make sure you follow the formula. I'll have it on Canvas announcements in mathematics once again for you so that you have access to all of those. So tonight you just have your introduction questions. There are 6 of them. You're finding the volume for each of the cylinders that I give you. If you have any questions though while you're working through these, please don't hesitate to ask us because we want to help you.